Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out 14 practice questions that should closely mirror what you'll see on the Mathematics Knowledge subtest of the Armed Services Vocational Aptitude Battery. If this is your first time finding my YouTube channel, I want to mention this. In order to get the most out of this video, I strongly encourage you to pause the video after I read each question, attempt to work out the question on your own, and then resume playing the video to check your solution. In the description of this video, I'm going to include timestamps that will be associated with each question. Next to the timestamp, there's going to be the topic that the question's testing, as well as a link to a video in which I discuss that topic in greater detail. So if at any point during this video you feel as if you need more help with one of the topics, just look in the description and there you'll find links to additional resources. What's more, I want to mention that on the ASVAB, you're not permitted to use a reference sheet or a calculator. So if you're going to be taking this practice test alongside me here on YouTube, try not to make use of any of those resources. So all that finally being said, let's go ahead and get started with today's video. All right, this first question says if a equals 6 and b equals 5, what is the value of 2a minus 2b in parentheses squared? So when you take the ASVAB, you're going to have scratch paper, and whenever you're given a problem where there's multiple things going on, I highly recommend you copy down the problem onto your scratch paper. Don't write out the whole question, of course, but copy down the essential parts. In this case, I'm going to copy down 2a minus 2b squared, and we're told that a equals 6 and b equals 5. So for this problem, it's pretty obvious that we're going to have to substitute 6 in for a and 5 in for b. But that said, the challenging part of this problem is the fact that we have to also follow the order of operations. So let's substitute those things in, and then we'll talk about the order of operations. So this becomes 2 times 6 minus 2 times 5, and that's all squared. All right, so the order of operations is best remembered by the acronym PEMDAS, or the phrase, "Please excuse my dear Aunt Sally." And this tells you the order in which you simplify expressions like this. The very first thing you'd work on is what's in parentheses. So in our problem here, we have something in parentheses, so we're going to work that out. Then you work on exponents next, then you do multiplication and division as they appear from left to right, and then finally you do addition and subtraction as they appear from left to right. Well, in this case, we have parentheses, so we're going to work on parentheses first. But once we're inside the parentheses, we then have to decide whether we're going to do this multiplication or this subtraction first. Well, again, according to the order of operations, multiplication comes before subtraction. So we're going to work out this multiplication first, and let's go ahead and do that. This is 2 times 6, which is 12, minus 2 times 5, which is 10, squared. All right, now we can go ahead and take care of this subtraction. We're still working inside parentheses. 12 minus 10 is 2. And the only thing we have left now is to square this 2. 2 squared, we should know, is 4. All right, so that's that one. Pretty simple problem to start. So let's go ahead and move on now. All right, so number 2 here says the hypotenuse of a right triangle has a length of 14 units and a side that is 9 units long. Write an equation to find the length of the remaining side. All right, so whenever you're dealing with hypotenuse and a right triangle, you should automatically think about using the Pythagorean Theorem. And the Pythagorean Theorem says this: a squared plus b squared must equal c squared, where a and b refer to the sides of the right triangle and c refers to the hypotenuse of the right triangle. All right, so let's go ahead and diagram right triangle just to see what that looks like. Again, according to the problem, we know we're dealing with a right triangle here. And this is our right angle. Again, C is our hypotenuse. how do you identify the hypotenuse in a right triangle? It's always directly across from the right angle. So right here, C, and then we can label A and B however we want. Again, as long as you identify the hypotenuse first, it doesn't matter how you label A and B. So I'm going to call this A, and I'm going to call this B. All right, and we're told what a few of these things are. Again, we're told that this right triangle has a hypotenuse that's 14 units, so we're going to let C be 14. And likewise, we're going to let one of the sides be 9. All right, so the way the Pythagorean theorem works is like this. If you're given at least 2 variables in the Pythagorean theorem, you can solve for the third variable or the missing variable. So if you're given A and B, you can quickly find C. If you're given B and C, you can find A. And if you're given A and C, you can find B. Well, in this case, we have C and A. So let's just go ahead and plug those things in accordingly. Again, A is 9, so this becomes 9 squared plus B squared equals C squared. C squared is 14 squared. All right, let's go ahead and solve for B now. Very first thing I want to do is get rid of these squares by expanding them. 9 squared is the same as 9 times 9, which is 81. So this is 81 plus B squared equals 14 squared. Now, I recommend that you learn squares from 1 to 20. But that said, if you couldn't work this one out mentally, you could always work it off to the side. This is the same as 14 times 14. 4 times 4 is 16, carry a 1. 1 times 4 is 4, plus 1 is 5. Before we start multiplication with this 1 here, we have to bring in a 0 placeholder. 1 times 4 is 4. 1 times 1 is 1. Let's add these together. 6 plus 0 is 6. 5 plus 4 is 9. And 1 plus nothing is 1. So this is 196. Again, we're solving for B ultimately, so we want to get B by itself. So the next thing we're going to do is subtract 81 from both sides. This crosses out, leaving you with B squared equals 196 minus 81. Again, if you can't do that in your head, it's always a good idea to work it off to the side so you don't make any mistakes. So we have 196 minus 81. 6 minus 1 is 5. 9 minus 8 is 1, and 1 minus nothing is 1. So this is 115. To get rid of this B squared, we're going to take the square root of both sides. This will cross out the square here, leaving you with just B. And we can see B is equal to the square root of 115. Again, according to this problem, we just had to come up with an equation for the length of the missing side. And as you can see, it's right here. B equals the square root of 115. All right, so again, you will see a question regarding the Pythagorean theorem on the ASVAB. Make sure you know it. And what's more, make sure you know how to solve problems where you're either given A and B, A and C, or B and C. All right, so that's that one. All right, number 3 here says 3 factorial is. Well, a lot of people aren't taught about factorials in high school. So let me give you a little refresher on factorials. A factorial means multiply that number by everything less than that number. So 5 factorial would be the same as 5 times 4 times 3 times 2 times 1. 4 factorial is the same as 4 times 3 times 2 times 1. All right, so if we're following that pattern, we would say 3 factorial is the same as 3 times 2 times 1. And now we're just going to work this out. 3 times 2 is 6. 6 times 1 is just 6. So 3 factorial is simply 6. This is a pretty easy problem involving factorials. As you can imagine, if you're going to score high on the test, they might give you something like this. 10 factorial over 5 factorial times 2 factorial. Okay, so just bear in mind, this is a very basic example of a factorial. They can get more complicated, in which case they'll look like this over here. Again, on my channel, I do have a video in regard to factorials where I work out easy examples as well as difficult examples. So if that's something you want to check out, I'll put a link in the description of this video. All right, so number 4 here says the factors of 2x squared plus xy minus 3y squared are. All right, so it's asking us to factor this quadratic equation. That said, this one looks pretty challenging. And let me say this, if you're asked to factor something on the ASVAB and it's not clear as to how to get started, what you want to do is actually work out the problem in reverse. What you want to do is go to your answer choices and expand those. And after you expand those, the one that matches the equation you were asked to factor is the correct answer. So that's what we're going to do in this case. Again, at first glance, I have no idea as to how to factor that. So what I'm going to do is work through my answer choices until I find one that matches this original equation. So let's go ahead and get started with that. Again, in order to expand this answer choice here, we're either going to use the FOIL method or just the distributive property, which means we're going to start by taking this 2x and we're going to multiply it here and here. Then we're going to take this 3y and multiply it here and here. So let's go ahead and do that. Again, to start, we have 2x times x, which is 2x squared. Then we have 2x times 3y, which is going to be 6xy. Then we have 3y times x, which is going to be 3xy. And then finally, we have 3y times 3y, which is going to be 9y squared. Let's go ahead and combine like terms. Again, 6xy and 3xy are like terms, so let's combine those. We have 2x squared plus 9xy plus 9y squared. We can't reduce this any further. So does this polynomial match what we were asked to factor? It doesn't, so we know that these are not factors of this equation. So let's go ahead and move on to the next answer choice. Again, we're going to expand this answer choice via the FOIL method or simply the distributive property. So we're going to take this 2x and we're going to multiply it here and here. After that, we're going to take this 3y and we're going to multiply it here and here. So let's go ahead and do that. To start, we have 2x times x, which is 2x squared. And then we have 2x times negative y, so that's going to be negative 2xy. Then we have 3y times x, which is going to be plus 3xy. And then finally, we have 3y times negative y, which is going to be negative 3y squared. Let's go ahead and combine like terms. Again, this is 2x squared. Our like terms are right here, negative 2xy and positive 3xy. 3xy plus negative 2xy is just xy, and then this is minus 3y squared. All right, so we reduce this. Does this match the original equation that we were given? We have 2x squared plus xy minus 3y squared minus 3y squared. All right, so since this polynomial matches this original equation, we know that these are the factors of this quadratic, and we're done. All right, so again, if you don't know how to factor something, you could go through your answer choices, expand them out via the FOIL method or the distributive property, and whichever one matches the equation you were asked to factor is the correct answer. All right, so that's that one. All right, number 5 here says, what is 8b minus ab plus 7a subtracted by 3a plus 9ab minus b? All right, so to set this one up, I want to go ahead and write this out accordingly. Again, this one starts with a and this one ends with a. So what I'm going to do is I'm going to rewrite this one so that the a comes first like this one. So that's going to be 7a minus ab plus 8b, and we're told this is going to be subtracted by, and it's going to be 3a plus 9ab minus b. All right, so in order to perform this subtraction, we actually have to take this negative and distribute it here, here, and here. So let's go ahead and do that. So this will become 7a minus ab plus 8b. And then let's distribute this negative, minus 3a minus 9ab. And then negative times negative is positive, so negative 1 times negative b is plus b. All right, so now that we've taken care of that, all we do is have to go through and combine like terms. Again, we have 7a here and negative 3a here. 7a minus 3a is going to be 4a. So we took care of those. Let's go ahead and cross them out. Now we have negative ab and negative 9ab. Negative ab plus negative 9ab is going to be negative 10ab. So we'll go ahead and cross those out. And then finally, we have 8b and b. 8b plus b is going to be 9b. All right, so let me just say this. I have a video that's about an hour long that's in regard to adding and subtracting polynomials. You'll see many examples like this one in that video. And in that video, I don't skip as many steps as I do in this video. So if you struggled with what I did here, you need to go ahead and watch that video on adding and subtracting polynomials. All right, so that's that one. Number 6 says, what is the product of a minus 1 and 2a plus 2? So let's go ahead and set this one up. We have a minus 1, and we're multiplying that by 2a plus 2. Well, as we've seen already in this video, we're either going to expand this via the FOIL method or simply the distributive property. So we're going to take this a to start, and we're going to multiply it here and here. Then we're going to take this negative 1, and we're going to multiply it here and here. Once we do that, we'll go ahead and simplify this resulting polynomial as much as possible. So a times 2a is going to be 2a squared. A times 2 is simply plus 2a. Negative 1 times 2a is negative 2a. And then negative 1 times positive 2 is negative 2. Let's go ahead and simplify this. We have 2a squared. Let's combine these like terms, 2a and negative 2a. 2a minus 2a is nothing, so these just go away. And then we're just left with minus 2. Now, at this point, we can reduce this a little bit further by factoring out a 2. And when we do that, we're left with a squared minus 1. And that is that one. Again, on my channel, I recently uploaded a video in regard to the multiplication of polynomials. So if you struggle with expanding things via the FOIL method or the distributive property, check out that video. But for the most part, this is pretty simple and straightforward. All right, so that's that one. All right, so number 7 here says the reciprocal of 3 1/5 is. So we want to find the reciprocal of the mixed number 3 1/5. Before we can find the reciprocal of this, we actually have to convert this mixed number to an improper fraction. And thankfully enough, that's pretty easy to do. To write 3 1/5 as an improper fraction, we're going to keep the denominator the same. So our denominator is 5 over here. That means the denominator of our improper fraction is going to be 5 over here. To find the numerator of our improper fraction, we do 3 times 5, which is 15, plus 1, which is 16. All right. So we've rewritten our mixed number as an improper fraction. And now to find the reciprocal of this improper fraction, all we do is exchange our numerator and denominator. So 16 is going to become our denominator, and 5 is going to become our numerator. And just like that, we are done with this one. Again, on my channel, I have a video that's in regard to everything you need to know about fractions. So if fractions are something with which you struggle, check that video out. Again, there's going to be a link to that video in the description of this video. All right, but that's that one. All right, number 8 here says the coordinates of points A and B are 2, 4, and -2, -4 respectively. What is the slope of the line that connects the 2 points? So in this case, we're being asked to find the slope of a line that passes through 2 points. And for that, we're going to have to know the equation to find the slope of the line. And that's given by this. M, which refers to slope, is equal to y2 minus y1 over x2 minus x1. And you might be saying to yourself, especially if you haven't seen this equation in a long time, what is x1, y1? What is x2, y2? Well, those are simply the points that you were given. Again, this is x1, this is y1, this is x2, and then this is y2. So all we have to do is plug those values in accordingly and then simplify. So y2 is right here, it's -4. So let's go ahead and put -4 right there. Minus y1, we can see y1's right here, it's 4. So this is -4 minus 4. x2 is right here, it's -2. So let's plug that in. Minus x1, which is 2. All right, so let's work on simplifying this. -4 minus 4 is going to be -8. And then -2 minus 2 is -4. All right, so in this case, we have a negative divided by a negative. So we know our result's going to be positive. 8 divided by 4 is simply 2. So -8 divided by -4 is positive 2. Therefore, we can say the slope of the line that passes through these 2 points is positive 2. All right, so that's that one. All right, so number 9 here says, which of the following is not a prime number? Admittedly, this is kind of a trick problem because if you watch my video on divisibility checks and prime numbers, you'd realize that one of the first things I mentioned is that 1 is not considered prime. So you could say 1 and be done with this one and move on. That said, in that video, I also showed you how you can use divisibility checks to determine if a number's prime or not. So let's just use 37 as an example here. In that video, I said you want to run divisibility checks for 2, 3, 4, and 5 to quickly determine if a number's prime or not. Again, a number's prime if it's only divisible by 1 and itself. So if 37 is divisible by 2, 3, 4, or 5, that means it's divisible by something other than 1 in itself, and therefore it's not prime. Well, to determine if a number is divisible by 2, you look at its last digit, and if its last digit is even, then it's divisible by 2. The last digit in 37 is odd, so 37 is not divisible by 2. To determine if something's divisible by 3, what you do is you sum the digits in that number. So in this case, we're going to do 3 plus 7. 3 plus 7 is 10. If the sum of the digits in that number is divisible by 3, then the number itself is divisible by 3. All right, so is 10 divisible by 3 evenly? It's not, so 37 is not divisible by 3. 4 is a little bit more tricky, and you can really only use it on 3-digit numbers. To determine if a number is divisible by 4, you look at the last 2 digits of a 3-digit number, and if those last 2 digits are divisible by 4, then the number itself is divisible by 4. Again, we only have a 2-digit number here, so this doesn't apply. And then finally, to check whether a number is divisible by 5, we look at its last digit, and if that last digit is a 0 or a 5, then the number itself is divisible by 5. And in this case, we have a 7, which is not 0 or 5. So this number is not divisible by 5. Again, the questions on the ASVAB might get more difficult than this. So if you want to check out that video that I made in regard to divisibility checks and prime numbers, I strongly encourage you to do so. It will help you out tremendously if you get a question like this that's a little bit harder on test day. All right, so that's that one. All right, so number 10 here says in the formula Celsius equals 5/9 times Fahrenheit minus 32. If Celsius is 35, then F equals. All right, so let's start by copying down what's given here. We have Celsius equals 5/9 times Fahrenheit minus 32. And we're given what Celsius is. We're told Celsius equals 35, and we want to solve for Fahrenheit. That is, we want to get F equal to something by itself like this. All right, so let's plug in 35 for C. This becomes 35 equals 5/9 times Fahrenheit minus 32. All right, so we're solving for F, which means we want to get F by itself. The very first thing I want to do is clear this 5/9 from this side. And in order to do that, I'm going to multiply it by its reciprocal, notably 9/5. And I'm going to have to do that to both sides of the equation. This crosses out here and here, so this just leaves you with F minus 32 over here. But that said, we have to take care of this 9/5 times 35 now. So let's go ahead and work that out over here. We have 9/5 times 35. That is to say we're multiplying a fraction by a whole number. Well, we could rewrite this 35 as a fraction by placing it over 1. And once we do that, we can actually reduce this prior to multiplying these two fractions together. 5 goes into 5 one time, 5 goes into 35 7 times. So this becomes 9/1 times 7/1. Anything divided by 1 is itself. So this is the same as 9 times 7. And 9 times 7, of course, is 63. So we can see that this 9/5 times 35 reduces to 63. And again, we're just solving for F at this point. So we want to get F by itself. So we're going to add 32 to both sides now. This crosses out here, leaving you with just F on this side. And now all we do is have to add these two together. 3 plus 2 is 5. 6 plus 3 is 9. And in math, it's customary to write the variable for which you solved on the left. So this is F equals 95. All right, so that's that one. A little bit of work to solve for F, but nothing too difficult. All right, number 11 says the graphs of the following equations are straight lines except. All right, so we want to look through all these equations and identify the one that's not a line. Well, as far as lines go, they come in two forms. One form's slope-intercept equation, which is y equals mx plus b. And then we have the standard form of a line. That's ax plus by equals c. These are the two generic equations of lines. And what do you notice about them? Their variables of y and x are both raised to the first power. Again, we can see that y is raised to the first power here, x is raised to the first power here. Likewise, in standard form, x is to the first power and y is to the first power. So in other words, you can tell if an equation's a straight line or not if its x and y's are all raised to the first power. All right, so this is raised to the first power, this is raised to the first power. That's a straight line. Again, y is to the first power here, x is to the first power here. That's a straight line. Y is to the first power here, x is to the first power here. That's a straight line. Here we have y equals x squared. Again, since that x is raised to the second power, we know that it's no longer the equation of a straight line. In fact, whenever you have something raised to the second power like that, the shape of your graph looks like this. It becomes a parabola. If you have something to the third power, it looks like this. So again, you can quickly tell if something's a straight line if x and y are both raised to the first power, once you raise either y or x to something other than the first power, you get a totally different graph. All right, so that's that one. All right, so number 12 here says, what is the area of a triangle with a base of 8 feet and a height of 4 feet? Well, thankfully enough, this one's pretty simple and straightforward. Again, you have to recall that to find the area of a triangle, you take 1/2 and you multiply it by base times height. And thankfully enough, we're given both base and height. According to the problem, our base is 8 and our height is 4. So let's just plug those things in accordingly. This becomes area equals 1/2 times base was 8, so this is 8, and the height was 4. All right, and let's try to work this out so it's very simple. 1/2 times 8 is 4, so this becomes 4 times 4. 4 times 4 is 16. So the area of this triangle that has a base of 8 and a height of 4 is 16 square feet. All right, so that's that one. Very simple. But that said, you do have to understand how to find the area of a triangle for the ASVAB. More specifically, you have to memorize the formula. Area equals 1/2 base times height. All right, so that's that one. All right, so number 13 here says the perimeter of a square is 84 feet. What is its area? So we know we're dealing with a square in this case. So let's go ahead and make a square. And what do we know about squares? Well, in squares, all the sides are equal. So all these sides are equal. What's more, we should know that to find the perimeter of a square, we simply add up all the sides. So if I let this side be x, that means this side's x, and this side's x. Again, to find the perimeter, we just start here and add up all the sides. So this becomes x plus x plus x plus x. All right, so x plus x plus x plus x is 4x. And we know what the perimeter is. We're told the perimeter of this square is 84. So in light of the fact we know what P is, we can go ahead and substitute that in. This says 84 equals 4x. Now we're just solving for x at this point, so we're going to divide both sides by 4. This crosses out, leaving you with x equals 84 divided by 4. You should be able to do this mentally. 8 divided by 4 is 2. 4 divided by 4 is 1. And again, x refers to the length of the sides of the square. So in reality, we're dealing with the square that looks like this. 21, 21, 21, 21. Well, how do we find the area of a square? Area of a square is always side times side, or some people write it as side squared. Again, we know what the sides of this square are. So this is area equals 21 times 21. And let's go ahead and work that off to the side so as not to make any mistakes here. We have 21 times 21. 1 times 1 is 1. 2 times 1 is 2. Before we start multiplication with this 2, we have to bring in a 0 placeholder. 2 times 1 is 2. 2 times 2 is 4. 0 plus 1 is 1. 2 plus 2 is 4. 4 plus nothing is 4. So the area of this square is 441 square feet. All right, so that's that one. And let's go ahead and move on to the last problem now here. The last problem says, what is the product of the reciprocals of 2/3, 1/8, and 5? So first things first, let's find the reciprocals of these. So we got 2/3, we'll find the reciprocal of that. 1/8, we'll find the reciprocal of that. And then 5, and we'll find the reciprocal of that. Then we'll just multiply all those together since we want the products of the reciprocals. Again, as I mentioned in this video already, the reciprocal means you're just going to exchange the numerators and the denominator. So the reciprocal of 2/3 is 3/2. The reciprocal of 1/8, again, just exchange those numerators and denominators, is 8 over 1. And this one's not so obvious, but I did mention this in the video already. To write a whole number as a fraction, you simply place it over 1. And now we can quickly find its reciprocal by exchanging its numerator and denominators. So the reciprocal of 5 is 1 over 5. All right, so here are our reciprocals. And now all we do is have to multiply them together. This becomes 3 over 2 times 8 over 1 times 1 over 5. And thankfully enough, multiplying fractions is pretty simple and straightforward. Again, you just multiply straight across. So this becomes 3 times 8 times 1 over 2 times 1 times 5. And my pen is starting to die here, so just bear with me. Let's go ahead and work this out. 3 times 8 is 24, times 1 is just 24. So this is 24. 2 times 1 is 2. 2 times 5 is 10. All right, so we're not quite done. We now have to reduce this as much as possible. And it should be obvious that 24 and 10 have a common factor of 2. So we can reduce this by dividing the numerator, 24, and denominator 10 by 2. 24 divided by 2 is 12, and 10 divided by 2 is 5. Again, we're not quite done yet because, again, this is an improper fraction. What is an improper fraction? An improper fraction is a fraction in which the numerator is bigger than the denominator, and whenever you have that, chances are high that you're going to have to convert it to a mixed number. So we're going to have to convert 12 over 5 to a mixed number to get our answer. Thankfully enough, this is pretty easy to do. All we do is treat this like long division. So I'm going to read this as 12 divided by 5. How many times does 5 go into 12 without going over? That's 2 times, given that 5 times 2 is 10. 12 minus 10 is 2. All right, so we have enough to write our mixed number. Again, this is going to be our whole number. This is going to be our numerator. And then this 5 is going to be our denominator. All right, so the answer to this one is 2 2/5, which is the same as 12 over 5. All right, so that is it for this video. I hope you found it helpful. As usual, you're more than welcome to leave feedback in the comment section below. Again, these questions closely mirror what you'll see on the ASVAB, so make sure you understand the ins and outs of all these problems. Regardless, I hope you found this content helpful. If you like the content I'm creating, please consider subscribing to my channel. But on that note, I'm going to go ahead and catch you loose. Konnichiwa.